Hi there, welcome back. Hope you had a good weekend. We're going to take a look at graphing sinusoidal equations. Okay? And the first thing we're going to do is take a look at how these are set up. And these are set up by looking at where the x value right here is the angle measure and the y value is the output, which is the coordinate. Okay? And if we remember, when we're looking at our unit circle, okay, we have the coordinates of x and y, okay, being the cosine and the sine. Okay, so the y value is the sine, the x value is the cosine. Now, if we're looking at this right here, y is the output. That's either going to be our x value or our y value. The x value in this case is just going to be the angle measure that we're looking at. So let's take a look at this real quick. Okay, I'm going to graph sines around. Okay, now, so here we go. This is at 0 degrees. What's the sine at 0 degrees? Well, it's the y value. What's the y value here? It's 0. Okay, what's the sine at pi over 2? Okay, well, it's the y value at pi over 2, which is 1. What's the sine at pi? It's the y value, which is 0. What's the sine at 3 pi over 2? Okay, which is the y value, negative 1. And then the sine at 2 pi, we're back to 0. Okay, so take a look at how we're going to graph this equation. Y equals the sine of x. Okay, I want to make that straight and nice. Here we go. Okay, good. Okay, so what's the top of our graph? What's the highest point we get? Well, we get to 1. So I'm going to call this 1. And what's the smallest part we get? Negative 1. Okay, and this is 0. Okay. On the x values, which are the angle measures, we start at 0, okay, and then we have pi over 2, and we have pi, and then we have 3 pi over 2, and then we have 2 pi. That's around the circle, okay? And those are the important points because those take us to what's called our amplitude, or our highest spot, okay, or our negative amplitude, which is our lowest spot. Okay, so the sine starts at where we're going to eventually talk about HK, but in this case, 0, 0, right? 0 is your x value, your angle measure, and 0 is your output. Okay, so we're starting at 0, 0, and then we go to the x value is pi over 2, and that's at 1. And then we're at pi and we're at 0. And then we're at 3 pi over 2 and we're at negative 1. And then we're at 2 pi and we're back to 0. So a sine curve looks like this. Up, down, back up. And it would just keep going as you went around and around and around the circle. But it would look like that. It's called a sine wave. Okay, let's look at what this would look like for the cosine of x. Now, when we have our coordinates, okay, x, y, as coordinates, okay, we have cosine and sine. So now we're looking at the cosine, okay, the x value. So here, when we have y equals cosine of x, this x value is actually an angle. That's the angle. This would be the coordinate. The y value would be the coordinate, okay? So we're looking at this. We have our angle at 0. Okay, what's the x value, the cosine at 0? That's 1. Okay, we're graphing a cosine here. Okay, and then we have pi over 2, and our cosine value, our x value, is 0. And then we have pi, and our cosine value, our x value, is negative 1. And then we have 3 pi over 2, and we're at 0. And then all the way back to 2 pi, and we're at 1 again. Okay, so our graph y equals the cosine of x is going to look like this. Okay, our inputs are going to be our angle measures, we're going to have 1, 2, 3, 4 of those as we go around the circle. There it goes, clicks in for me nicely. Okay, now our cosine, okay, I'm going to put that as 1, and that as -1, and this as 0. Okay, those are our output values. Okay, our cosine, the x value, the angle was 0, and the coordinate for cosine is 1. So we're going to start up here. 0 angle, we're at 1. Now at pi over 2, we're at 0. At pi, we're at -1. At 3 pi over 2, we're back to 0. And then at 2 pi, we're all the way back up to where we started at 1. And that's going to be graphing 1 period from where you started to where you end. Okay, so it's going to look like that. So that's 1 period of a cosine. And I always do it kind of loopy like this. I never start here and do this. It's not a V, okay? It's a rounded curve. You got to get your flow going. Okay? All right. Now those are the basic graphs of your y equals sine of x and y equals cosine of x. Okay? And they actually look the opposites. Okay? If I pull this back, you can see how they're kind of opposite looking. Okay, let's move down. Let's now start shifting these all over the place. We're going to shift them side to side, up and down. We're going to make them go faster. We're going to make them go bigger as far as amplitude. We're going to do all sorts of things. Okay, so let's take a look at how we shift our graph. Okay, let's look. Hopefully we see this as being a little bit familiar in that there's an H and a K. The H is going to be the side to side shift. The K is going to be the up and down shift. The A, this is called amplitude, okay? And it comes straight from like sound waves, okay? The amplitude is how high up and how far down your graph goes, okay? And this B is actually the angular velocity, something you might see in physics at some point, but it basically just says how fast do we go 360 degrees or 2 pi. That would be your B, okay? We're going to use this a lot. I'm not going to worry about defining it too much, okay? But it's basically how fast you're going around the circle. Okay, looking at all this stuff, here's what we're going to dig out of every problem that we have. We're going to have, let's see here, I got a better place where this comes up. Okay, every problem we have, we are going to have a K, an A, a K, an H, an amplitude, a B, a P, which is our period, okay, and then an each notch. Okay, so we're going to dig those out of here, okay, and this is y equals K plus A sine of B times X minus H. Okay, that's our basic equation. Okay, so in this one, our K is 2. Our H is 1. Why is it 1 and not -1, right? We see it's the opposite of what you see. That negative is going to change out to be positive, right? Because of negative H. Okay, and it's very similar to the parabolas that we're graphing. Our amplitude is 3. Our B is pi over 6. Okay, you'll see the B's are a lot of times in terms of pi. Okay, our period is always going to be 2 pi over B. Okay, well in this case, we've got 2 pi over 6. Okay, which equals 2 pi times, this is divided by pi over 6, times 6 over pi, right? Multiplied by the reciprocal. Well, take a look at this. Cancel, cancel, 12, right? Okay. Each notch is our period divided by 4. Okay, so in this case, it's 12 divided by 4, which is 3. Okay, so you're going to dig that out of each question. And I know some of you are overwhelmed right now, but that's why this is recording. You can go back and watch it. I'll also be holding a Zoom meeting on Tuesday. Show up, and I'll explain it more and take your questions. All right, here we go. So I need to kind of pull this in a little bit so I can graph it all. Okay, so how do we set up the graph? How do we do these? Okay, the graph's always going to look like this. Okay, something like that. All right, now what do we have? We have, I like to do my y coordinates first. So my first coordinate is k, which is at 2. I'm just going to mark it like this. Boom, right there. Call it k equals 2. Okay, k plus a is going to be up at the top. K plus a. That's my midline plus my amplitude. So I'm going up like here, and I'll call that, boom, k plus a is 5. Okay, because that's the 2 plus the amplitude of 3, which is 5. K minus a is at the bottom, and that is going to be negative 1, because that is 2 minus 3. So I go up to 5 and down to negative 1. Okay, I always dash my midline too. Oh, I didn't do it. Okay, anyway, a dashed midline because I'm going to go back and forth on there. Now I'm going to mark my x values. Well, my first x value is the h. Boom, h. Okay, so I'm just at 1. Mark it here, 1. Okay, and then I'm always going to have 4 marks after h to represent going around a circle at 90, 180, 270, and 360. Okay, so after h, I'm going to mark 1, 2, 3, 4. Okay, and then each notch after h is going to add 3. So 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, plus 3 is 13. And if you'll notice, 12 is our period. Well, what's the distance from 1 to 13? That's 12. Okay, so we're going to go through an entire cycle here. 1, up, down, and back to the start. Okay, in 12 units. Okay, so here we go. We're going to start at HK. Boom, right here. And then it's a positive sign, so we're going to go up to the K plus A at our next notch. And then we go back down to the midline, down to the bottom, back to the midline. Okay, so I kind of lost that dot there. All right, here we go. So this is how I'd graph. Okay, so it'd look like that. They're all going to look like that. What's really going to change is our K plus A, our K minus A, our H, and these. But the actual graph is always going to look like this. Our scale, our numbers on the side are going to look a little bit different every time, depending on what's going on there, right? What's going on with our shifts and all that stuff. Okay, what's going on in here? Good grief. Hopefully no one got dizzy there. Okay. Anyway, all right, let's keep moving. I'll do 1 or 2 more. These are our basic graphs. As you can see, I just showed you what every sine curve is going to look like. It's going to start at HK. It's going to go, if it's positive, it's going to go up to the amplitude, back to the midline, down to the bottom, back to the midline. Okay. A cosine is going to start at the top, go down to the bottom, or go down to the midline, down to the bottom, back to the midline, back up to the top. Okay? This will be very useful as you go back and look at it. All right, taking a look at this one. We are looking at y equals our k plus our a cosine of b times x minus h. Okay, and we're going to fill everything in here. Okay, our k is 3, our h is 1, our amplitude is 2, our b is pi over 4. Okay, our period is 2 pi over b. So that's 2 pi over 4. Now watch what will happen. That's the same as 2 pi times 4 over pi, right? Multiply by the reciprocal. Cancel, cancel. That equals 8. 2 times 4. Now, each notch is the period, which is 8 here, divided by 4. So it's 8 divided by 4, so that is 2. So that's going to be each notch I write out on the x after h is going to be adding 2. All right, here we go. Gonna graph it. They all kind of look the same. Okay, I might need to make this a little bit taller here. We'll see. Okay, all right, here we go. What's our k? K is at 3. I'm just going to mark it, call it 3. K equals 3. I want you to say it just like that. K equals 3. What's our amplitude? Well, it's 2. So up here at the top, K plus A equals 5. Down here, K minus A equals 1. Right? Dash the midline. All right, now we have to work on our x values across. Well, we start at h. H is 1. And then after h, we do 4 notches. Just make them the same distance between each. I like to give myself a little room to work. 1, 2, 3, 4. Okay? Now, what is each notch? Each notch is 2. So I'm going to add 2 after h. H was 1. Add 2, I get 3. Add 2, I get 5. Add 2, I get 7. Add 2, I get 9. And if you'll notice, once again, that our period is 8, we're going to go through a up, down, back to the start, and from 1 to 9, which is 8 units, right? The distance there to there is 8. Okay, here we go. We are on are we on a cosine or a sine? I don't even know yet. Now I look back, I'm on a cosine. Cosines start at their amplitude. If it's a positive cosine, which this one is, it's going to start up at the top of the amplitude, K plus A. Cosines always start there. Right here. Okay? And then we're going to just, next notch down, we're going to head down. Boom. Next notch down, we're going to head down. Just to our bottom, right? Not to 0, but to 1, because that's our negative amplitude. Next notch, we're going to work our way back up. Right there, and then we'll head up to the top. Okay, I always like to round my cosines because I don't want you to graph these like a V. They kind of look like a V, but they're not. They're rolling hills. Rolling hills or waves, like this. It helps me to make noises as I draw it. Okay, and then just keep going and going and going. All right, very good. That should basically do it. One more? Why not? Let's take a look at it quickly. All right, what's our K? 1. What's our H? Pi? That's weird. Okay, great. What's our A? 3. Now, some of you said negative 3, but the amplitude is an absolute value. Okay, so it's just 3. All right, we're going to worry about this negative later. Okay, our B is 4. Okay, well, what's our period? It's 2 pi over b. Pi over 2, right? As you reduce that. Each notch is period divided by 4. So pi over 2 divided by 4 is the same as pi over 2 times 1/4, right? Flip and multiply, we get pi over 8. Okay, it's kind of a weird one, but we'll take care of it. Good. Okay, so here we go. I'm going to graph it up here. Okay, again, the graphs all look the same. Take a look at this. Boop. Okay, where's K? K is at 1. Mark it. K equals 1. What's our amplitude? 3. I'm going to move this a little bit. The amplitude is 3. So we're going to have a little bit up. K plus A equals 1 plus 3 is 4. Okay. K minus A equals negative 2. Right? Because 1 minus 3. All right. What is H? H is pi. Boom, mark it, pi. And then I've got 1, 2, 3, 4 notches after H. Always. It doesn't matter what the scale is, all that stuff. Just write it that way. 4 notches after H. Each notch is pi over 8. So this is kind of a tough one here. Okay. 2 pi over b. I'm just checking my work here. Period divided by, and then 4. So that is times 1/4. Yeah, pi over 4. Okay, so here we go. All right, so this is like 8 pi over 8, right? Which is pi over, or which is 1 pi. 8 pi over 8 plus one more 8. Okay, so I'm 9 pi over 8. Oop, I gotta write this. 9 pi over 8. And I remember having to do this one as an example because it was a tough one because it's weird. 10 pi over 8. 11 pi over 8. And 12 pi over 8. Okay, so those are my notches. Doesn't matter, the scale is shown to me this way, okay? Always go H, and then 1, 2, 3, 4 notches. Okay, so we're on a sine and we're on a negative sign. Negative signs, or signs, always start at HK. That's right here, okay? Negative signs start by going down. Instead of going to the top of the amplitude, they start by going down. So on my first notch, I'm at the bottom. And then I'm back to the middle. And then I'm up to the top. Then I'm back to my midline. Sine curve is going to look like this. Done deal. Okay? We can go over that one again if you want to. That is a difficult one. What I'd like you to do for the homework. Okay? Let's do 1 through 4. Get those done. Okay? And I'll talk to you on Tuesday. All right. Thank you. Good work.